In this video, we look at the derivation of the loan formula, and we derive this loan formula from what we call the ordinary annuity equation. Okay, so let's go through that now. We know that the amount of money in an annuity at any moment in time, t in years, is given by the initial amount of money called the principal that is allowed to grow at an interest rate of R annual interest compounded n times a year for t years. So this is part of the compounding of interest of the principal. And then if we are making payments into this annuity on a regular schedule, we know that the payments are also going to accrue interest, and the formula would be 1 plus r over n to the nt power minus 1 divided by r over n. This is the ordinary annuity equation. Okay, recall that our definitions are P0 is called the principal. This is the initial amount that is invested. Okay, R is the payment. Okay, this number is going to be a positive number. A positive number for R indicates that we are making deposits into this annuity account. And then we know that R is equal to a percentage. That's the annual percentage rate, N being the number of compoundings, and T is a time in years. Okay, so if we look a little closer at this ordinary annuity formula, please notice that it is of the form P of T, and then we have P0 times this number here, this thing underlined in pink. I'm going to call that number 1. Okay, and then you'll notice that there is a number here. I'm going to call this number 2. This complicated part, I'm going to call this number 2. So if you want to know the value of an annuity after T years, it basically breaks up into two different formulas. It breaks up into the P0, the principal, times this number 1, and then we're going to add on to that payments multiplied by this number 2. And you'll make an observation here. Note that number 2, that equation that's underlined twice, that's also equal to number 1, right? You can see that part of the equation right here, number 1 minus 1 divided by r over n. So that's this formula explained as an annuity problem. So for example, just making sure that we're good with the ordinary annuity equation, and then we'll move on to the loan formula. So as an example, let's say that you start with P0 is equal to, say, $100 in an account, and you're going to make a payment of, let's say, $25 every month, and that payment every month corresponds to the number of compoundings, 12. We're compounding 12 times per year, right? And let's say that the interest rate is like, say, 5%, okay? And then we want to allow this money to grow for say 30 years time. Okay, the question is, how would we find the amount of money in the account after 30 years? It's going to be the 100 multiplied by number 1, whatever that first number is, and then we are going to add on to that $25 plus $25 times whatever we come up with for number 2. Okay, and to do this number, we need to compute this on a calculator. Okay, and I'm going to show that calculator step over here on the left in Desmos, and show the kind of the way I would do it, try to do this efficiently as possible. Okay, so we want to take the numbers that we have on the left, on the right there, and I would like to turn them into Desmos. Okay? So I want to come up with number 1. I want to figure out what this number is. It is 1 plus the interest rate of 0.05%. So that's the annual interest rate, and we need to find the interest rate per period. So divide that by 12, and then raise that to the 12 times 30 power. That is the number in number 1. There's a second number, right, that we've noticed here on the right is coming from, the number on the right is the first number, number 1, minus 1, and then we can divide all of that by R 0.05 divided by 12. So now we have a number 2 is equal to 832. So I think what we can see here is that to find the principal after 30 years, I'm going to do 100 times my first number plus 25 times the second number in 2. And that means that after 35 years, right, having only $100 to start with, right, that we are going to have after 30 years $21,000 to $21,253 and say 24 cents. Okay, so that is how to use the annuity formula. Okay, so I'm going to take this formula. This is called the ordinary annuity equation. And then we're going to turn this into a loan problem and rearrange it into the loan formula. Okay, so let's do that on the next page. Right, and so we're going to start with the ordinary annuity equation. Okay, so I'm going to write P of T is equal to P0 times that first number. I'll let you look at the previous page to see what that was, plus the dollar amount that we're investing every time period multiplied by the second number. Okay, and I guess I will for completeness write where number 1 is equal to 1 plus R over N to the NT power, and number 2 is equal to number 1 minus 1 divided by R divided by N. Okay, so those are what those numbers are. Now to transition to loans, let's do this in blue. We want to transition to what is called a loan problem. We need to just rethink of our definitions. P0, rather than being the initial amount that you've invested into the annuity, if we transition to a loan, we're going to think of P0 as the amount that has been borrowed. This is the amount borrowed. And so, for example, this could be maybe like $5,000 that you have borrowed to buy a car. So maybe this is for your car payment. Okay? Let's say that you don't know what the value of R is. This is your car payment. You don't know your monthly payment. Okay? That's what we're going to try to find. Finding the car payment or finding the payment R value in the formula is essentially what the loan formula is. So we're going to assume that maybe you have an annual interest rate. You borrowed the money at a certain amount of interest rate. So for example, maybe like 5% APR. Okay, and this APR is now, rather than being a thing that is helping us and making our money grow, you might actually interpret this interest rate, interpret this as a fee that as a fee for borrowing the $5,000. So this interest rate is now a fee. You can think of it in that way. And let's say that you're going to choose 12 because you might want to make monthly payments. So interest is being accrued on a monthly time period. Okay, and then typically T is the time. Let's say that we know this. Let's say maybe this is 5 years, and so this is what is called the term of the loan, and it's basically how long, sorry, it's lowercase, how long do you have to pay off the loan? Okay, and now I can interpret P of T is that this is the value of the loan, how much you still owe, how much that you owe on, for example, your car after T amount of years, right? And the goal is to pay this off. The goal is we want to pay off this loan. And when you pay off this loan, that means that you have zero amount that you owe. Okay? So now what we're going to do is to reinterpret. There's one other reinterpretation problem here I'm going to do, and it's at the payment level. When you're making payments, that's not a deposit. When you're making a payment, your payment is negative. You are taking money away from yourself, right? So our payment is minus $200 or minus $300. You're making a payment, okay? And so now we can kind of put all this together. We can take the ordinary annuity equation, okay? And we're going to transition that into a loan formula. And I'm going to pay off the loan. So I want 0 to equal to the principal, how much I owe on the car, for example, $5,000, times number 1, okay? And then our payments were going to be minuses, so we want to make a payment, so that's minus R times number 2, okay? And basically the idea here is to find the loan formula is to simply solve for the variable R. And when you do that, when you solve that for R, you would add R times number 2 to both sides of the equation. R times number 2 is equal to P0 times number 1. And then we want to solve for R. So R is equal to the principal, the amount that's owed, multiply that by number 1, and then divide that by number 2. And this right here, this formula is called the loan formula. Okay? As an example, for example, we could take the numbers that we just had. P0 is equal to $5,000 to buy a car. Okay? You had maybe an interest rate of 5%. You had 5 years to pay that off, and we were going to make monthly payments. Okay? And the question is, we want to figure out what is the R value have to be for the value in the future of the car to pay it off. The future amount is 0. And we want to know what value of R does this. Okay? So the way to do it would be to go to your calculator and to use the loan formula that we have below. Okay? And I will show how the similar techniques for ordinary annuities, the formulas can apply in this section also. Okay, so I'll go through the same method. Get rid of some of these. I don't know where these came from. Okay, so let's take a look. We need to take all of our numbers and find number 1. Okay, this is equal to 1 plus the interest rate, the fee that was being charged for you to borrow that money. That was 5%. The interest rate per period is going to be 5% divided by 12. We're going to raise that to the 12 times. We had 5 years to pay this off. So there's our the N1 value. Number 2 is, as it was before, number 2 is equal to number 1 minus 1, and then we need to divide by the interest rate 0.05 divided by 12. So there we have our N1 and our N2 values, and my claim is that if we want to find the payment to pay this loan off, I need to take my principal, which is the $5,000 that I've borrowed, multiplied by N1, and then we need to divide all of that by N2. And this tells me that the amount that I'm going to have to pay each month to pay off this loan is $94.36, and this is a per monthly payment. So ends this video.